Okay, so in order for this construction to be true, as it were, to be exactly 90 degrees, here, here, here and here, there's a number of different options we have in order to achieve that. The most approximate way, of course, is just to use the eyes. The eyes are very, very good at discerning something off, or something that's not quite level or straight, but it's not so easy to be sure that this angle is 90 degrees. And it needs to be 90 degrees, of course, in order for the base to be consistent and everything that comes from this to be true and in integrity of form, shape and structure. And there is a point at which it's necessary, and this is a key pivot point to get this right. Now, as you can imagine, we have fixed and nailed together each of these points that the wood joins together. But of course the structure can be a little bit this way, meaning it could be like a parallelogram, and we need to adjust it. So one method, of course, is to get a tape or a string from this far corner all the way over to there, and then do the same from here all the way to there. And if those two lengths of string are the same, that means that everything is aligned into a perfect rectangle. That's one method, and for sure we're going to use that to double check everything. You can use one of these tools as well, but you know, it's set for 90 degrees and you can place it here, but you can see it's not consistent. And this could be because this wood is rough planed. It's treated wall plate wood. It's rough planed. It's not machined to perfection at all. So even though there might be, you know, a feeling that this is good enough, in these key moments, good enough is not good enough. So there is another method, and we'll show it to you now. And this is quite beautiful because it touches geometry and the whole essence of it. One of the Pythagorean theorems is that if you have a rectangle, hopefully you can see it, I might turn so you can see this better, like so. If you have a rectangle, or in this case we're going to go for a triangle, in order to be sure that this angle here is 90 degrees, which is what we want, you can measure it. Doesn't matter what scale, but we're going to go for 3 units here, 4 units here. And if this is 5 units long, then that's exactly 90 degrees. And the theory, not the theory, but the proven, the proof of this is that if you were to put a square here, and it consists of 3 times 3, and again you were to put a square here, which would be 4 times 4, if you can see this. You can also do a square here, which I don't have enough wood, but you can imagine is 5 times 5, bum bum bum. So 4 times 4 is 16, 3 times 3 is 9, 9 and 16 equals 25, and 25 is 5 times 5. That's the proof, as it were, so that when this is true, we have 90 degrees exactly here. So in practical reality, what I did was, this length here, I measured with the tape in units of 50 centimeters. That's one 50 centimeter, another up as far as this point here. And you can see 150 centimeters is 50 by 3 units. So it's 3 units of 50. And then on this side here, bum, 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 4 units of 50, which is 20 centimeters. So by placing a tape measure, or in this case just for visual showing, of a tape measure or some wood, the shadow is actually not helping so much, but this is the point in here. You can see my finger. I could put it on the outside actually so you can see better. There's the mark, and over on this side there is the mark again, if you can see that. So that when we measure from here all the way over to there, we should get 5 units, which in this case would be 25 250 centimeters. So I'm working alone on this, so that's not perfect, but we will see when we go across to here. You can see 250, and the extra is because it's not pure over there. So it wasn't correct before. We were 4 or 5 millimeters out. So what Herky did was, he's talking Estonian here now, he literally just kicked this corner a little bit, kicked that corner a little bit, and the result was, bang, we are right. So the internal angle here we now know is a perfect 90 degrees. So what we'll do next is the same mechanism over on this far corner. And assuming that is right, and we keep this one consistent, then we'll finalize it with 2 diagonals of string. And that will give us our perfect rectangular base. And we know then, and we can be sure and confident that everything we do from this is, perfect is not the right word to use when you're in construction, but it is practically perfect. And it's beautiful to know that and to work with it. And indeed it saves time, energy and material later, because any inconsistency, as in life, any drop of integrity in a key moment has the effect of accumulating the imbalance, the disharmony, if you will, to a point that it's going to manifest. In this case, could manifest in a joint just not meeting at a later point, or excess of material needed, or excess of stabilizing structure. All told, if we get it right at this point, we can effectively relax, and by that I don't mean do nothing, but we can continue to work in the knowledge that this step was integrated coherently. More later. Thank you.